Year 10. So if you open up at page 56 for me please in your notes, then we'll get ready to get started. Okay, so you can see here what we're doing. We're going to be looking at finding the gradient of a straight line. Now, this is such a useful skill, and again, selfishly I'm talking about this because it comes up in physics quite a lot as well, right? So, yeah, we're finding the gradient of a straight line. So just a quick summary on what it actually is. A gradient of a line is really a measure of its steepness. So say if we look here and we've got like line A and line B. Do you see how line A is much steeper? So we would say it has a higher gradient than line B. Now, another little thing is that I will talk about lines going up or going down. And whenever I'm doing that, I'm really meaning like whenever you're going from left to right. So see the way going from left to right here, both of these lines are going up the way. They'll have a positive gradient. Whereas, spoiler alert for one of the examples, see the way this one, as we move from left to right, is going down the way. We will end up finding that it has a negative gradient, okay? So there's a few different ways that you can calculate the gradient. Now, now this is strange because see if I teach you in maths and then I teach you in physics, I'll probably teach you two different ways to do the gradient depending on what subject I'm teaching. Because in maths I tend to do the more mathsy way, whereas in physics I use a much more straightforward way. However, the way that not more straightforward, that's a lie. I think it just looks more straightforward than it actually is. The calculations are all the same, but my physics method relies on you knowing what a gradient is and really relies on you knowing that wee bit about going up being positive, left to right, and going down being negative, because the wee physics way will not give you that negative. Whereas the better, and I will admit, the better way is the more mathsy way, and it will always tell you whether a gradient is negative or not. Okay, right, enough rambling. I'm gonna go and start doing this example now. I should have said, actually, see here, the gradient, really, this is what I would say is the physicsy way of doing it. The gradient is the difference in the y coordinates divided by the difference in the x coordinates. Can I get you to write down another version of that just underneath here? This is probably the way I'm going to do it. So the gradient is y2 minus y1 over x2 minus x1. Okay, write that down for me, please. This looks more awkward than it actually is, I promise you. Okay. Now, we have to find the gradients of these three lines. I'm going to call this one line 1, this one line 2, and this one line 3. Okay, so we're going to end up squashing our working out here a wee bit. Let's try our best. So line 1. Right, to find the gradient, you have to pick 2 points on the line, and then we're going to carry out this calculation here, okay? Pick nice points. By that I mean points where your lines cross on the grid nicely. So I'm not going to choose like this point here, that would be silly, right? So I'm going to choose for this one, probably going to choose this point here, and this point is the point 1, 5. And let's choose this one. Okay, I could have gone for the end one, but I'm trying to show you that it doesn't have to be the two ends of it. So this point here has the point minus 3, or sorry, has the coordinates minus 3, 1. Okay, so see if we're doing this method here where the gradient is y2 minus y1 over x2 minus x1. Well, we have to pick one of these points to be like point 1 and one of the points to be point 2. So I'm going to call this point here point 1. So that means x1 is 1 and y1 is 5. And this point x2, y2. Okay? And I just want to show you that this is exactly the same as this. Difference in the y coordinates, that's all I'm doing here. I'm doing y2, take away y1. Difference in the x coordinates, I'm doing x2, take away x1. Oh, I think I've labelled those points the most awkward way ever, sorry. But sure, it'll show us that we still get the same answer no matter what way we do it. So back to this line 1. Gradient is y2 minus y1 over x2 minus x1. So be super careful. Refer back. So y2 is 1. I've got that from over here. Minus y1, which is this one. That gives us 5. Over x2 is this one. Minus 3. Minus x1, which was 1. So 1 take away 5 gives me minus 4. Divided by minus 3, take away 1, minus 4. Minus 4 divided by minus 4 gives us 1. So, do you see what I mean about how I labelled these a wee bit awkwardly? It meant we were dealing with a lot of negatives, but it all worked out in the end because we were careful. So that is the gradient of line 1. And a gradient of 1, and I'm just going to ramble on a wee bit here, a gradient of 1 just means that for every one square you go across, or one scale point I should say, you go across, you go up 1 as well. If we had a gradient of 2, it would mean that for every 1 we went across on our x-axis, our graph would go up 2. Okay, so that's all the gradient means. It's just a measure of the steepness, and the higher the number, the steeper the line. Right, let's do line 2 here. So let's pick 2 points here. I really am going to have to pick the 2 end points, aren't I? I'm going to say this one, which is 3 minus 5. I'm going to call it the 1 point this time. So this one is going to be x1, y1. And then on this one, this point, which is 4, 3, it's going to be my point 2 this time. So this is x2, y2. Okay, so line 2, gradient is y2 minus y1 over x2 minus x1. y2 is 3. Take away y1 is minus 5. x2 is 4. Take away x1, 3. So 3 take away minus 5 gives me 8. Because remember, taking away a minus is the same as adding. 4 take away 3 is 1. So my gradient is just 8 divided by 1, which just gives me 8. Okay? And then we'll be able to fit in our working out for line 3 over here, just about. So, if we look at this line here, let's pick 2 points. Let's go for this one, which is the point 1 minus 4. And let's go, do you know what, I may as well go for the end one. Let's go here, and let's call this point minus 5 minus 1. Now, remember, it doesn't matter which one you choose to be x2, y2 and which one you choose to be x1, y1. As long as you're super careful, it will all work out. So I'm gonna go x1, y1 for here, x2, y2. Right? Now, gradient y2 minus y1 over x2 minus x1. Let's refer back to our graph. So y2 is minus 4. Take away y1, which was minus 1. Oh, we're going to have to be super careful here. You watch me, because I'm bound to make a silly mistake. Right, x2 is this one, 1. Take away x1 is this one, minus 5. Right, I'm going to have to work up here. So now, please be careful. Minus 4, take away minus 1. Do you know what? I'm going to simplify it. Is minus 4 plus 1. and then 1 take away minus 5 is the same as 1 plus 5. Hopefully that'll stop me from making silly mistakes. Minus 4 plus 1 is minus 3. 1 plus 5 is 6. So our gradient here is minus a half or minus 0.5. Let's stick with a half. This is all a little bit messy, so I'm just going to like draw a wee line around that to like separate it out. Oh, I can't cope with how all over the place it is. But there are our answers. So line 1 has the gradient of 1. Remember that means for every 1 you go across, you go up 1. Line 2 has a gradient of 8, which means for every 1 you go across, you go up 8. Line 3 has a gradient of minus a half, which means for every 1 you go across, you go down half a square, or for every 2 you go across, you go down 1 square. But I'm kind of annoyed with myself for talking about that, going across a square and down a square and up a square and all, because remember, squares don't always have the value of 1, so you always have to refer back to the scale on your axis, not just counting the squares. Now, the work that you need to do today, I think it's actually, there's something in your notes, but I'm going to change it a little bit. Hold on, let me find my right page. Okay, page 57 is another example. I'm actually going to leave it for today, okay, because I want the focus today to just be doing those gradient calculations like that. So, do you know what I want you to do? Basically, just question 1 from exercise 3 here, but if you look, it's for each graph of exercise 2, which you did last week. Now, it was the last lesson that we did on this stuff before the test. Choose 2 points on the line and calculate the gradient of the line. But just in case your graphs are a bit dodgy, I'm going to also give you a PDF which has all of these graphs drawn on it, so I'll show you that now, okay? Right, so attached to this assignment as well is going to be this PDF, and there's a few different pages in it, and it's all the graphs from that exercise 2 drawn out. So I think you had to draw the line y equals x, you had to draw the line y equals 2x, y equals a half x, etc. What I want you to do is to either use the ones that you have drawn already, right? Or use these ones and calculate a gradient for each of the lines, okay? And then that is it. That is your classwork for today. I don't want to do too much new stuff on this in one go, especially when we're not in a proper classroom, so that I'm there to help you as and when you get stuck. So that is it for today. Give me a shout if you need any help. Okay, bye.